This video is sponsored by Squarespace, the best way to make an amazing website. So I made quite a few videos last week discussing what we should expect for the future with Apple's upcoming ARM-based Macs, but I'm still getting comments where people aren't fully understanding the benefits of Apple silicon, with some people claiming that they'll ditch Apple once Apple ditches Intel. Now, what a lot of people don't understand is that Apple's transition isn't just about switching to ARM-based processors. There's actually a whole lot more to it that will greatly benefit Apple's future Macs. So in this video, I'm gonna dive deep into how their upcoming SoC technology is gonna work, how it compares to current x86 processor technology, and why it makes sense for Apple. But first, I want to let you know that our limited edition Apple Silicon ARM t-shirt is available in our merch shelf just below this video. Currently, Intel-based Macs like the 16-inch MacBook Pro have a CPU, a dedicated GPU, memory for each of them, and more recent Macs have a T2 chip, which adds things like a storage controller and coprocessors. With Apple Silicon, all of that is going to be built into one system on a chip, or SoC. The main benefit is that all of those components, from the CPU to the graphics, the memory, the new neural engine, and the machine learning accelerators will all be able to communicate with each other much more efficiently compared to before. So let me give you an example from Intel-based Macs. Current dedicated GPUs have to communicate with the CPU using the PCI Express bus, which means there is added latency. I found some white papers from semanticscholar.org discussing this. So here's a quote from a paper named Efficient Data Communication Between the CPU and GPU. Limited by low bandwidth and high latency interconnects, larger paper migration has longer delay, which may reduce the overlap of computation and transmission and cause serious performance decline. So when there's more latency, like when you're using PCI Express for the GPU, the rest of the system, like the CPU, have to wait before they can continue processing, reducing overall performance. Here's a quote from another page titled Unlocking Bandwidth for GPUs. In the near future, systems will appear where software page migration is an optional choice, and hardware cache coherence can also support the GPU accessing CPU memory directly. And this is exactly what Apple is doing with their new ARM-based Macs. If you look at this old diagram from 2015, you'll see that at the bottom, the GPU and CPU have a cache coherent link, which raises the bandwidth from 16 gigabytes per second to 100. Except in Apple's case, the GPU will now have direct access to system memory on top of all of that. So basically, Apple's thought process is that if they can greatly reduce the latency in communication between all of the components, then each component has less of a wait time before it can start its specific tasks, and system performance in general will go up thanks to increased efficiency. And this ultimately means that you can get better real-world performance with less raw power, and that's before accounting for software optimization, which Apple Silicon will greatly benefit from, since Apple will directly control both the hardware and the software for the first time ever on a Mac. That's the exact same reason why the iPhone is the fastest smartphone in the world, while also getting great battery life. And this is also why our 2020 iPad Pro is now over 20% faster in terms of graphics performance just by upgrading to iPadOS 14 beta. So control over both hardware and software means incredible optimization. Now, before I take a deep dive into the future potential of Apple Silicon compared to Intel's x86 chips, I want to give a huge shout out to Squarespace for sponsoring this video. If you've been thinking about getting your own website, Squarespace is seriously the best way to go. I built an engaging website for my wife's cleaning business with literally no webmaking experience. You just choose a template, customize blocks of text and images, and easily move them around. It's incredibly simple, affordable, and it's been running flawlessly for almost 2 years, bringing in new clients thanks to its built-in SEO tools. So whether you're making a website for a small business or for literally anything else, so whether you're making a website for a small business or for literally anything else, go to squarespace.com for a free trial and use our custom link below when you're ready to launch to save 10% on your first purchase of a website or domain. Back to Apple Silicon, people are comparing the A12Z chip from the 2020 iPad Pro to current Intel chips to see if it's worth it, but this is actually a mistake. First of all, the processor side of the A12Z is basically unchanged from the A12X chip from 2018, since Apple chose not to improve it again since the competition is still nowhere near the 2018 iPad Pro. That chip is made using 7nm technology built by TSMC, the leader in ARM chip manufacturing. Now, Apple's upcoming Mac family of SoCs will actually use the 5nm fabrication process, and according to TSMC, that should bring a 15% performance improvement per watt. But it doesn't stop there. TSMC has confirmed that they'll be shipping 3nm chips in 2022, and that should give us another 10 to 15% performance boost per watt. So if we take the current A12X chip from 2018 and change nothing at all except for switching out the 7nm chip for a 3nm chip, the performance will go from a Geekbench 5 multi-core score of 4,606 to between 5,700 and 6,000 points. Those scores are much higher than Intel's brand new 10nm i7 quad-core chip from the 2020 13-inch MacBook Pro, and that's coming from a much smaller chip that is passively cooled in an iPad Pro that's 38% thinner than the iPhone 11 Pro. Now, what a lot of people don't realize is that the Apple Silicon chips that'll be used in the Macs are gonna be a brand new family of chips, which means that Apple is most likely gonna scale the size of the chip much larger now that they don't have to fit it in a thin tablet. And they're also gonna allow it to use more power, since the batteries in Macs are much larger than the ones in the iPad Pro, and they'll be able to add active fan cooling, giving them a lot more thermal headroom. However, these Apple Silicon Macs are going to have much better battery life since they'll be using asymmetric cores, meaning that they'll have both high performance cores and efficiency cores. And those scores from before don't factor in any other improvements made by Apple, which could be memory speed and further optimizations. So that was just the future potential of the processor side of Apple Silicon. Now let's get into the graphics side. I already made a video explaining why Apple is no longer going to use dedicated graphics chips for their consumer Apple Silicon Macs. The graphics will be built into the main chip, which, like I mentioned earlier, will greatly reduce the latency in terms of communication between the CPU and the other components. So like I said, you can get more real-world performance with less raw graphics power. Now, if you don't believe me, let me prove it to you. We recently compared our Mac Pro to a Windows PC in terms of video editing. As far as raw performance, you can see that the PC had over twice as much processor performance and over 60% more graphics performance than the Mac Pro's AMD Vega 2 GPU, so the PC is clearly much faster. However, when we tested video editing using DaVinci Resolve 16 Studio, which is a cross-platform program, the Mac Pro was actually faster at exporting a 5-minute raw 6K clip. And even while stabilizing a 1-minute 4K clip, the Mac Pro was yet again faster than the PC, showing that raw performance doesn't always mean more real-world performance. And that test was without considering the new technology that's coming to Apple Silicon Macs. But let me remind you again, the A12Z chip in the super thin iPad Pro currently has about 20% more graphics performance than Intel's brand new 10th generation i7 processor in the 2020 13-inch MacBook Pro. Now just imagine if they scaled up the processor and added benefits from everything being packed into one main chip, like the unified memory architecture. Some users commented that this shared memory is too slow compared to the current GDDR6 memory in dedicated graphics chips, but they're completely forgetting that Apple Silicon Macs will have their own dedicated on-chip tile memory, which could very well be the incredibly fast HBM2 RAM. So check out this example by Apple showing how developers can optimize the graphics to access the tile memory more often so that it won't have to access the system RAM as often, reducing the use of DRAM bandwidth. So Apple's goal is to streamline graphics processing to free up as much system memory bandwidth as possible, which will in turn reduce the chances of a bottleneck, and then combined with incredibly low latency, every component in the entire system can be utilized much better than on a traditional x86 Intel processor. Like for example, Apple's T2 chip, which currently takes care of HEVC transcoding, which will now have reduced latency since it's built into the same main chip instead of being somewhere else on the motherboard like it is in current Intel-based Macs. These are the types of improvements that will allow Apple to achieve great real-world performance even if they have less raw performance due to no longer using large dedicated graphics chips. So now let me finish off with two more major benefits of Apple's silicon. Macs will be even more secure than ever before now that they're ditching Intel and its many hardware vulnerabilities like Meltdown, Spectre, Zombie Load, and much more. And a huge benefit to Apple Silicon is that we no longer have to deal with AMD graphics driver issues. The same issues that cause your 16-inch MacBook Pro to overheat when connected to a display. With Apple's ARM-based Macs, all of that is going away. But of course, this is a major transition and it won't be perfect right out of the gate, since it could potentially take developers a year or two before they fully optimize their apps for Apple Silicon. So if you're as excited as I am for Apple's ARM-based Macs, be sure to check out our limited edition ARM t-shirt just below this video and click the circle above to subscribe for more videos like this one. And if you're wondering how gaming on the Mac is going to be affected, definitely check out that video over there. Thanks for watching and we'll see you in the next one.